Okay, this is a video on A, which is logs and exponential functions. So A1 was just like converting between logarithmic and exponential form, and then learning all the laws of logs. And then A2 is just on transformations and being able to graph log functions. And then A3 was the trickiest one, and that was when we solved logarithmic equations. Okay, so let's look at A1 to start with. Oops. Okay, sorry. So let's check out A1. So laws of logs. So we learned these were the three main ones. So if you had, for example, log A plus log B, as long as they have the same base, so these ones both have a base 10, then you can combine them by multiplying. So it becomes log AB. If you had log A minus log B, as long as you have the same base, by dividing. And exponents, so if you had log base 10 A to the power of B, you could write that as B log A. So you can put the exponent out front. So those were our three main ones. And then we're just going to quickly talk about exponential form to logarithmic form. So that's where if we had something like 2 to the power of 3 equals 8, and we just wanted to see what that looked like in log form. Log form, we write the exponent as our base, so, we write the base as the base of our log, so 2, we write the answer right here, and then we write it equal to the exponent. So log base 2 of 8 equals 3. So sometimes you might have to convert back and forth between the two forms. And that was pretty much all of A1. And A1 you had to do a bunch of simplifying of laws of logs, which I didn't make any questions on. So just to show you a couple. So say we had log x plus log x squared minus log x. I don't know, it's a horrible example. So the first two are addition, so that means you can multiply them. So we get x times x squared, and then the next one's subtraction, so that means we can divide it by x. And if we wanted to simplify this, we could actually just cancel out those x's, so this would just equal log x squared. There's simple ones, so just like log 6 plus log 4 would be equal to log 24. So simplifying with laws of logs, so this is just like continued from above, just means that we're going to write in the expression, you want to write it with just having one log instead of multiple logs. Okay, so then we're moving on to A2, which was transformations and graphing. So you had to be able to graph just straight log functions without the transformation. So just being able to graph log 2 of x. And if you can never remember what that looks like, I mean, feel free to think about it, like just sub things in. So you know that this stands for the exponent and this stands for the answer. So if you sub things in for y, so say, because y is our exponent, so say we subbed in 1, or say we subbed in 0 for y, so 2 to the power of 0 will equal 1. So I know when y is 0, x will equal 1. If I want to sub in 1 for y, then I know 2 to the power of 1 will equal 2. If I want to sub in 2, I know 2 to the power of 2 will equal 4. If I want to sub in like a negative 1, 2 to the power of negative 1 will equal a half. So I know my log function is going to actually look like this. It's going to have an asymptote at x equals 0. It's got an x-intercept at x equals 1. That's pretty much it. So you can do the same thing with the base of a half. If you're not sure what it looks like, just try subbing things in for g of x. So when g of x equals 0, well, x is still going to be 1 because a half to the 0 is equal to 1. If we sub in 1, a half to the power of 1 is a half. A half to the power of 2 is a quarter, so we can see it's getting smaller. So if we try subbing in -1, a half to the power of -1 is going to be 2. So you can see this graph just looks like this. So it's also going to have an asymptote x equals 0. It also has an x-intercept at 1. That's pretty much it. Then we looked at transformations. So we're just going to talk about transformations happening to the graph of log base 3 of x. So here we've got a vertical stretch by 2. This plus 1 here means we're moving left 1. And this one here means we're going down 5. This one was tricky because you kind of had to convert it beforehand. So we're going to write this as log base 3. And instead of having a root x on the bottom, we're going to move it to the top. But that means it's going to be a negative exponent if we're bringing it up. And since we have a square root, the exponent of a square root is a half. So it becomes x to the power of -1/2. And using our laws of logs, we know we can put that exponent in front. So we have -1/2 log base 3 of x. Okay, so what that negative does is a reflection in the x-axis. And the 1/2 is going to be a vertical compression by a half. The one example I didn't do, which is the weird one, let's say we had g of x equals log base 3 of 2x. So just to remind you that when there's something in front of the x, that's our horizontal, and it's always backwards. So it's actually a horizontal compression by a half. So it's always by 1/k. So those are our transformations. So that was A2. And then finally we've got A3, which was solving logarithmic equations. Okay, so the first example, I can recognize that I can make these both have a base of 2, because I know 2 to the power of 2 is 4, and then there's an x. And I know 2 to the power of 3 is actually equal to 8. And I'll just keep this other stuff in a bracket. And once we make the bases the same, we can just make their exponents equal, which I just expanded this one. So 2x equals 6x plus 12, so then we've got -12 equals 4x if I rearrange everything. And if I divide both sides by 4, I get x equals -3 as my answer. Okay, this one, 5 and a 7, not as easy to make the bases the same. So if you can't make the bases the same, one strategy is to take the log of both sides. Gets a little messy. And then we can use our log of logs to bring down our exponent. And 2x plus 1 can go in front of log 7. So this is 1 log 5. And this becomes 2x log 7 plus 1 log 7. Then we're going to move everything around, and we're going to get the x's on one side and the numbers on the other side. Minus 2x log 7 is equal to log 7 plus log 5. I'm going to factor out an x. Log. So get log 5 minus 2 log 7 equals log 7 plus log 5. Whoops. And then I'm just going to divide both sides by what I've got in the brackets. so that my final answer is log 7 plus log 5 over log 5 minus 2 log 7. And you can just leave that as your final answer, or you can calculate it and figure out what it equals. Okay, which, if you plug it into a calculator, which I just did, hopefully I did it right. But it's totally fine if you want to leave it like that. Okay, next two questions. We got log 2x plus 10 equals 2. So for a question like this, you know you have a base 10. You could just switch this to exponential form. So it becomes 10 to the power of 2 equals 2x plus 10. So 10 to the power of 2 is 100 equals 2x plus 10. And then I just rearrange stuff. So I get 90 equals 2x. And x equals 45. For a question like this next one, maybe using a log. So the addition law, where we multiply, so we got x times x plus 2 equals 3. So we combined our logs. Now we can use the strategy from the other one. So now we can say, oh, base 2 exponent 3, 2 to the 3 equals x squared plus 2x if I were to expand the brackets. I know that's 8, so I'm actually going to move it to the other side. So I get 0 equals x squared plus 2x plus 8. And then to solve this, if you can factor it, that's awesome, but you can't. So you'd have to use the quadratic formula. B squared, which is 4 minus 4ac over 2a, which is 2 times 1. I'm going to end up with, I think, no possible answers, because I got 4 minus 32. Okay, so I'm going to end up with a negative under here, negative 28. Yeah, so I can't solve this. So there's actually no solutions, which makes sense because I just made this question up. But essentially that's what you would do, and hopefully I would make one that's factorable. Not in this case because there wasn't anything. But if I don't, then quadratic formula could work. And then you just got to remember to check for extraneous variables. So like, remember our graph of these? So notice how there's no negative x values in these graphs. So log base 2 of x, it doesn't exist over here. So if you get an answer that is negative for questions that are involving logarithms, you can just go ahead and eliminate those. So you don't want the negative solutions. Yeah, essentially that's it. There's some weird ones for A3, but I think I might have made other videos on them. Like, let me just show you one more weird one. Those ones that are like 2 to the 2x plus, I'm not going to make up a good one. You know what? I made a video on it, so just watch that. But yeah, that's pretty much all of A.